Next, our colleague Tim Kuhlmann will interview Florian Lindner from the company Conco, who will present a project to highlight how Open BIM enables time-efficient structural design.
Thank you very much, Ilona, for the introduction and for handing over the moderation. Hello from my side as well. My name is Tim Kuhlmann, and I am very pleased to welcome you to the Frilo stream as part of the launch event. After my colleague Manuel Walter has just presented the new features in Frilo 2026 to you, we would now like to use this part of the program to build a bridge from the software applications to practical use. That's why today I have invited Florian Lindner, a longtime user of both Frilo and ALLPLAN, as my guest. Welcome, Florian.
Hello, Tim. A warm welcome from my side as well. Thank you very much for having me. I'm looking forward to some exciting minutes ahead of us.
So, Florian, you're about to present an exciting project from your daily work to us. But before we get started, I'd like to ask you to briefly introduce yourself and the engineering office where you work.
Sure, just a quick word about myself. As Tim has kindly already introduced me, I'm Florian Lindner. I come from a practical background, trained as a reinforced concrete builder, did a dual study program, completed my bachelor's degree in civil engineering in Regensburg in 2017 and in 2019. Then finished my master's degree in Munich, and I'm currently doing further training to become a specialist planner, fire protection at IPOS, and I am currently working, since January 2024, together with my two business partners, Mr. Huber and Mr. Diekwal, I have been managing director at the engineering firm Concon. We are a comprehensive engineering firm covering all areas from structural design to fire protection, thermal insulation, sound insulation, and also planning. And recently, thanks to my partner, Mr. Diekwal, we are also working as expert assessors and preparing reports. So in the end, we have a portfolio that covers all areas of planning, except for HNS and ILT planning. We don't do those. Otherwise, we can handle everything quite well. And I think we have a very good practical user perspective, which we can briefly present to you now.
Thank you for the brief introduction of yourself and also of Eures Engineering Office. Now I'm curious to find out which construction project you will be presenting to the viewers, what challenges you overcame, and how the solutions from Frilo and ALLPLAN supported you in the process. Florian, the floor is yours, so I'll hand it over to you.
All right, thank you very much. Exactly. Today, as part of our event, we're focusing on Open BIM. That's what we've called it. In structural engineering, using the example of a four-sided farmstead. As Tim already mentioned, our aim here is to build a bridge to practical application. Where do we start a project and how can we further develop it? By exploring the possibilities that the software tools from ALLPLAN and Frilo have provided us in the planning process. As Kurz already mentioned, the project is the Vierseithof in Seiwoldsdorf, here in our southeastern Bavarian region in Traunstein. The project is not exactly a small project for us either. But we're talking about 4 apartment buildings that are built on a shared underground parking garage. The underground garage is constructed with paving and individual foundations. The basement floors, meaning the cellar rooms and storage rooms, are built on a concrete slab foundation. The construction method is classic solid construction. We have reinforced concrete ceilings and walls. We used masonry, and the attic floors are built in timber construction with timber studs and a traditional roof truss structure. There are 50 apartments here, arranged in various sizes. This part, subsidized by EOF. The apartments are, of course, barrier-free. Our client for this project was the Traunstein Housing Association, WBG Traunstein. The goal of this project was to create affordable housing, which nowadays is a very exciting challenge for many planners and also for developers. Furthermore, the project was to be built to the KfW 40 standard, and that's exactly how it was ultimately implemented. Where do you start with a project like this, especially when we get involved early in the planning phase? Phase 3, for example, we receive an architectural model, in this case from the firm Guggenbichler and Wagenstaller from Traunstein. Here you can see the floor plan showing how the project is structured. Of course, there are many more plans as well, sections, various floor plans. And in addition, we were also provided with an IFC model from the architects. This allows us to use the interface aspects as efficiently as possible. From this system of IFC interfaces and the model we received from the architects, we were able to immediately set up and model the project internally in ALLPLAN. We were able to import it using the available interfaces here and had to do relatively little additional modeling work. For this project, we covered our specialist areas in ALLPLAN, fire protection, sound insulation, and above all, reinforcement planning and structural engineering. This allowed us to prepare the interfaces relevant to us internally relatively quickly and easily. As you can see here, this is an excerpt from ALLPLAN. We can also briefly look at it here in the model to see what the building looks like. We have the 4 buildings and we have an underground parking garage. Down here you can see the individual foundations and the basement levels. And in practice, it really was the case that with the import via the ALLPLAN interface, relatively little modeling work was required. And this model, as we have just seen, is actually more or less one-to-one. That's what we got in ALLPLAN as a result of the import. The next step in the process is, of course, very relevant for us as structural engineers. The interface, how I package the whole thing into a sensible design, receive. And here, Frilo offers, in my opinion, a very, very elegant and beautiful way to use the BIM connector FBC from Frilo. You can see it here on the left side. I'll show that directly here in the connector as well. Some of you will already be familiar with it. This model also arrived one-to-one from the ALPLAN interface via the BIM connector FPC. You have 2 models here. The physical model, where the wall thicknesses are essentially represented as filled areas. And then there is the calculation model, which is the relevant model for us as structural engineers. Here we might have just briefly seen the switch. The wall becomes a line so that we can model the load transfer as efficiently as possible. And here too, we can already see, for example, in the underground garage. Here you see the individual columns, the components, linear elements, and beam elements as girders. So essentially everything is packaged in a very, very elegant and efficient workflow. The work that still needs to be put in here, as the structural engineers among us will certainly know, is that you have to adjust wall offsets and small eccentricities. However, in my opinion, the added value is clearly there and very beneficial, as I have already mentioned. Because I simply have the geo model available very quickly, unlike in the past when you had to click through everything yourself using DXF overlays in the background, and I don't have to build all the walls myself in Frilo or model the slabs. In this case, the interface makes all of that possible. Exactly. So how does it continue once we've developed and built our model in ALLPLAN and transferred it to the FBC, imported the physical model, and then, let's say, cleaned up the analytical model? Then it continues in the classic way in Geo. I think everyone here is quite familiar with precisely how, within the Frilo application, the crucial Geo and PLT calculations are meticulously performed in this particular and specific manner. This process is fundamental to understanding its functionality. The FPC provides the interface to Geo. That means in the FPC, and we can quickly show this again, I have here the FPC export function. I can directly design slabs. I can create a building model calculation in Geo. This is the approach we always use internally in our office. And it's also very elegant because I then have a finished Geo model here, which as a structural engineer, I can use again. The basis for my structural calculation is that I have a clean, and at the end of the day, I also have verifiable structural analysis and calculations on the table. As soon as I have exported my Geo model from the FBC, of course, the process continues here. You always have to make small model adjustments, so you shouldn't and you should not approach things without engineering judgment. And as is often the case, not blindly trust the programs, so you need to have some input there. As the responsible structural engineers, we still have to do that ourselves. We finish modeling the model. The load applications are added so that we apply permanent loads and then variable loads as a checkerboard to the individual components. And then at the end of the day, you can go into what I call the conventional design of the slabs. I think everyone knows this, the Geo interface, where I can export my slabs in Geo, export my masonry walls, calculate my columns, and so on. Here too, Frilo offers the full range so that at the end of the day, you have a very comfortable an option to carry out the calculations. Exactly. Now we've briefly looked at where we started with the architect's model with the permit plan using IFC. We imported it into the old plan, then we imported it into the BIM connector FPC. We moved over to Geo all the way to output and design in PLT. So you might be asking yourself, where is the big advantage, the big benefit? And here I can definitely speak for us project specifically. The work steps have simply become much easier. In my opinion, it's an absolutely great workflow that Freelo offers here. You can import the models quickly and easily into the FPC. Of course, for first-time users, it will be a bit of an adjustment in some areas. With the first model, it might not go quite as smoothly yet, but it's definitely worth the experience. And I'm a big advocate of that as well. As I've already said, you always have to clean up and check the model from an engineering perspective. But the path into Geo has been made relatively easy for you, so to speak. In the past, at least for us, it was often the case that you would build models, export DXF layers, import them into Freelo, into Geo, and then manually select all the walls. And that's, I would say, the big player behind it, the fact that you can save a significant amount of time here. Personally, I think the bigger the project, the greater the time savings. With a small single-family house, the effort might not be 100% worth it. The structural engineers among you will certainly know what I mean. But especially with a project of this size, as we've just seen, the added value is really significant. For us, the added value was also especially there because we could use the existing plan model to, we were also able to optimize our processes right away, especially when it came to reinforcement planning. The reinforcement argument is actually the next point I'd like to address. Let me briefly show what happens once I've finished the GeoPLT design. What does that trigger? It means that in the end, we still have the designer who ultimately has to implement everything at the end of the day. And here as well, Freelo and ALLPLAN offer, in this case specifically, ALLPLAN provides fantastic possibilities. You can display the reinforcement beautifully in 3D here, including intersections and bends at these beam intersection points, as you can see in the image at the top left, and model and build them directly into the design. And so in the end, if I think through the entire workflow, we just started with the architect's plan, and now we're here with the finished reinforcement, which you can view in 3D. Here too, with ALLPLAN, we have a solid foundation so that in the end, we have a proper execution plan for the trades on the construction site. Exactly, here we have another small excerpt showing how it is possible to represent everything in ALLPLAN. At the bottom left, you can see the interface options and what the foundation elements look like now. You can see the individual footings, the slab sections, the rising columns, and exactly that. In the end, this is the final product that results from the initial basics we have available, as described at the beginning. It should also be mentioned here that ALLPLAN, with the structure it offers for reinforcement planning, is excellent. We make extensive use of this, especially regarding all the color options and the way the plans are presented. In our opinion, this is here, ALLPLAN is also very good for the engineering representation of reinforcement plans. So here as well, the usability is excellent. Exactly. And at the end of the day, of course, we always have the final product on the construction side. After all our theoretical planning steps that take place in the office, which we have already discussed. And so in this project in particular, we were able to, of course, as is often the case, the time pressure was definitely there. I think that's something many people are familiar with. The plan is ready. And then, of course, it needs to be implemented as quickly as possible. And we managed to do that here. We especially managed to do it. And this really needs to be emphasized because the process from creating the architectural model to the structural model to the reinforcement model was simply a very straightforward, well-structured and fast workflow. At the end of the day, everyone on the construction site was happy. We were able to deliver a fantastic project. And just as you can see here in these excerpts, just now we saw these beams represented in 3D in ALLPLAN, and now we see how they are being assembled on site, the reinforcement cages. Exactly. At the end of the day, we were able to complete the Vierseithof in a very efficient planning timeframe. Here you can see another picture of what it currently looks like. We have nearly finished the 4 houses. The first houses, house 1 in fact, will already be occupied this October. And because we actually had to implement this at short notice, here again is the major added value from my personal perspective regarding the global structure of ALLPLAN in connection with Frilo. Here, we were able to save a significant amount of time and use all these connections between the programs with absolute efficiency. And thus also meet the desired timeline of the client, and then in connection with the implementation on the construction site, the construction companies as well, very, very well, implemented efficiently and to everyone's satisfaction. Exactly. At this point, we've covered all the content. Of course, that was a very quick run through. I certainly hope that many of you, if you haven't already, will find and seek out the path via the ALLPLAN FPC and Geo interface. The first time might be a bit bumpy, but I can assure you, in my opinion, it's definitely worth it. Give it a try. Have fun with the Frilo interfaces, FPC Geo. It's worth the attempt and the experience. And I'm quite certain that it won't just be a one-time use, but that you'll find yourself using it repeatedly. Exactly. Thank you very much for your attention and enjoy the rest of the presentation day.
Thank you, Florian. A very demanding project in terms of planning and certainly an important construction project for Tronstein as well. And I'm impressed by how you in particular have leveraged the strengths of the BIM connector to idealize the structural framework for the statics as efficiently and reliably as possible. To wrap things up, let's maybe take a quick look at the upcoming release. I'd like to know from you, what are you most looking forward to in Frilo in 2026?
Yes, since, as we've already heard, we are both ALLPLAN and Frilo users, it's clear that we see a real advantage in the harmonization of the entire license administration. Ultimately, this global structuring and administration via the ALLPLAN connector in the customer portal will definitely be a great feature. Furthermore, if you think about structural analysis again, it's now the case that both for the foundation programs and for the design programs for steel connections, each can be linked to a powerful application. This means I no longer have to switch back and forth between the individual steel connection applications. Instead, I go into one steel connection and can directly access all the different areas within this single application tool, no matter which splice connection it might be. I simply have a unified structure, and it's the same with the foundation programs as well. In the end, I have one program, one application, and within this application, I can work through to determine which foundation I need. And finally, there is also the pre-stressed concrete beam. Personally, I think Frilo has done a great job in recent years and months by increasingly implementing these plus programs and simply making the usability and the user interface fit into a more modern working environment. This is being upgraded step by step, and now we also have the pre-stressed concrete beam included in it. And as I said, I think it's really great that Frilo is ultimately designing the working environments in such a modern way and always stays on top of things to make it as effective, pleasant, and enjoyable as possible for us as customers to use.
All right, yes, once again, thank you very much, Florian, for enriching our event today with your practical contribution and also for giving us a brief insight into what you are especially looking forward to with Frilo 26. It's great to see that the software combination of Frilo and ALLPLAN is so attractive and valuable for your engineering office. So yes, thank you very much for being here today. Take care and see you soon. See you.
All right, bye.